Hello everybody, and welcome to today's presentation, Docker Security, How to Protect Microservices in Production, brought to you by Sysdig. I'd like to introduce you to our presenter. Knox Anderson is a container aficionado working in product marketing at Sysdig, focused on security and forensic solutions for containers and microservices. Prior to joining Sysdig, he first discovered containers as an easy way to demo complex products like distributed SQL databases, and has been helping companies of all sizes make their experience of running containers in production easier. Well, without further ado, I'm going to turn things over to Knox to begin the presentation. Knox?
Hey everyone, thanks for having me. Another housekeeping item on my side. I like these sessions to be as interactive as possible, so if you have a question at any point during my presentation, please chat it in. I'll try and address it as I move through the presentation, and then we'll also have time at the end for Q&A as well. Before we get started, I'd want to put up a poll really quickly just to figure out where everyone is in their container journey right now. So if you're in production, if you're exploring it, if you're planning on using it, if you want to learn more, to kind of see where everyone is, how they've broken down in their journey, and the different things that we need to think about as we go through this presentation. So I'll keep it up for a little bit longer. It looks like 2/3 of you have answered now, so it's a pretty good mix. 75%. All right, once it gets to 80, I think I'll call it. So we're at 77, 78, 81. All right, awesome. So I'm going to close it really quickly, and we can look at the results. So what it looks like in the audience, we've got 20% of you using it in production right now, 45 in dev, 33 just exploring. So pretty much a good handful of everyone in the audience knows about containers, knows some of the challenges. And so what we'll do today is talk about some of the really practitioner-focused things about deploying security at different layers of your container pipeline. So I'm going to hide these back, and let's get started. All right, so what's on tap today? We're going to cover the challenges of securing microservices, but then we're actually going to also talk about the benefits containers can bring to security, the different stages of your container security lifecycle, the best practices at each stage, and then I'm going to do an intro to Sysdig, and then actually do something that no other container security or monitoring company will do, and we'll actually do a live instrumentation of a containerized environment, do some exploration there, and see everything that's going on. All right, so why is this hype train behind containers so big? Everywhere I look, Hacker News, it's Kubernetes, containers, all these different things. Really, developers love them. It's a faster development process. Something's going to run the same on my laptop, as a server, in the cloud, on-prem. It's making the development lifecycle a whole lot easier. Operations teams also love them. So you can use things like Kubernetes or Mesos to distribute services across multiple hosts. Doing rolling deployments and things like that is much easier with containers. And then business units love them as well. So you can get higher utilization out of your hardware, innovate faster, and build more reliable services as you're scaling out services with containers. But like any new shift, this has created a set of new challenges. So containers are essentially black boxes. The things that make them awesome, that they're isolated, they're portable, they're lightweight, also makes it really hard to see the performance of what's actually going on inside those containers, and then also making sense of them as they scatter across multiple nodes, multiple regions. How is everything correlated? So with that new dynamic architecture, how do you auto scale or alert or block activity on a service that is now distributed across hundreds of nodes and thousands of containers? And then it's also a whole bunch of new organizational processes that you're building in. So containers are ephemeral. That's awesome that I can bring them up, bring them down. But if something happens, how do I actually go and do troubleshooting on an entity that no longer exists? So this is something that we kind of need to think about as we move to containers, and are things that we're going to cover throughout this presentation. So they've really complicated that ability to see, analyze, and protect everything that's going on in your environment. And if anyone's listening and is like, oh, I've been through this before, this is something that's happened again. So each time when you went from physical to virtual to cloud computing, you kind of had to rethink your shift for storage, networking, security, and the tooling that you needed to bring into that environment is completely different. So it's a huge paradigm shift where you're really trying to catch up to where you were before. So the thing that really I faced when I first started with containers is this same shift that I've already done something that's going to happen again? And it's a really scary thought to people. It's like, oh, I've got to learn these new tools. I need to learn these, bring in these new business processes, all these kind of things. But what containers really do is offer a chance for better security with deployment security, with runtime security, and then also on your incident response and forensics teams. So containers are portable. The way you think about them on your laptop and your CI/CD pipeline in staging and production is the same. And it's really easy to build once and run anywhere. Orchestration is also going to allow you to kind of step back and abstract different services and make things a whole lot easier from that perspective. Since containers give you that isolation, there's less dependencies, less things that you need to pull in and manage. And then containers also make inventory management a whole lot easier. You can basically stamp out images and then have a really nice audit control of all your Artifactory metadata with awesome open source projects like Graphius to kind of bring those in and have a consistent log of what changed, what happened, and roll out deployments quickly. At runtime, that isolation is also really nice. The overhead is a much smaller attack surface. And then that single process isolation also makes it a whole lot easier to baseline the activities. So if a container has one process running inside it, you're expecting that process, you're expecting standard ports to be connected to. So if there is some type of behavioral anomaly, it's a whole lot easier to spot it when you have that isolation compared to a VM where you've got a bunch of different services running. And then that automation from your orchestrator is going to make it a whole lot easier as well. On the incident and response and forensic side, you can respond and recover much quicker with containers because of that startup time, because of hooking in with your orchestrator and rolling out a new image and things like that. There's also a lot of facilities built into Docker that make this a lot easier. So you can commit a container, quarantine it, and then run it again outside of your infrastructure to see what changed and how it might be impacting. But also on this incident response side, a lot of things are a little bit harder, and that's some of the tooling that we'll talk about later today. So we've got you covered, and you can have much better security if you architect that security around containers. So the first thing I'm going to cover is deployment security and the things you need to think about there. So first off, use the built-in features that are in your containers. So set container limits. By setting a limit, you're going to really protect yourself against resource abuse and things like that, and cap the physical utilization that container can be using. So if you deploy containers into production without limits, you're really you're not protecting yourself from kind of containers having runaway access to everything else that's going on in that host. The next thing that you really want to do is limit privilege. So containers are running as root, and if you give a container a privilege, it can run as root on your system, gain access to other containers, do a whole bunch of other things. So you really want to limit the privilege that you give to containers. And then if you have to give privilege to a container for specific activities, you're going to want to monitor that really closely. And then containers also have a lot of built-in signing and content trust built in. So you're going to want to validate that the containers that you're running in production have been signed, made it through your CI/CD pipeline, and everything else. And this signing is going to make it a whole lot easier to kind of look back and have this nice audit trail of everything that happened. Also scan early, but then scan often as well. So you're going to want to scan at a build time. And because it's easier to build containers, add things to them, scan at build. And then if this scan fails, pass it back to the developer. The model that I really like with containers is you build it, you secure it. And this is something that's a whole lot easier now because you have these isolated packages that you can rebuild and things like that. Also scale at deployment time. So before something goes in, you want to scan it, create that artifact to compare later to, and then scan periodically at runtime. So look at what's running in your containers, if things have changed, compare it back to your existing artifactory and things like that. Also, internally, have good container hygiene. So since it's easy to build containers, whenever new libraries come out, if there's some type of vulnerability, it's really easy to rebuild your images. So do that constantly. You really don't want your containers getting stale in your environment. So also monitor how long they've been up. If containers have been running for a month, that's something that's definitely too long. I've seen some organizations cycle containers daily, some hourly. Really depends on your workload, but make sure you know how long that they've been running and rebuild your containers constantly. Secrets management. A lot of people, when they start off containers, they're putting secrets verbatim in that pod or container. You really want to encrypt these, use some secrets management tool. This is built into Docker. There's also really good things with Kubernetes around secrets management, HashiCorp Vault, a lot of different options here. And then the thing that makes containers great from a development side, I can pull one down from the internet, get going, try out new technologies really quickly. But if you're using containers in production, you definitely want to set up some type of private repository where you're building things, pulling things out in there, scanning them, checking them into your own private repo, and only pulling from that for your production environment. So that's kind of a quick overview on the deployment side. On the runtime side, you really need to think about how you're instrumenting your environment. So one of the things that first comes off with people with containers is they go with a sidecar model. This is really hard from both a infrastructure perspective as well as a attack surface management. Container density, when it first started out, you might see 5 to 10 containers per host. Now we're seeing 20 to 30, and with some customers running hundreds of different containers per host. Having this sidecar instrumentation is really going to affect the performance of your systems and going to make it really hard to manage all the different tooling you have in your environment as well. Also, when you're instrumenting on the runtime side, you want a single point of overhead that's non-blocking the performance. So you don't want to go in and use a shim to look at the process, pause it, things like that. You really want something that's as less intrusive as possible, and that can collect all the data. And that then brings me to capture everything. So with containers, because of that isolation within your C groups and your namespaces, you really need visibility into the container, the host it's running on, and all the network connections. And then within the container, because it's built via system calls and kernel access, collecting system call data is something that is really important at the container level when people didn't really think about that as much before. The other great thing, and why all the hype is built around containers, is there's a ton of community activity here that is making it a whole lot easier to deploy containers and to get up and going really quickly. So the first thing I'd like to call out is the CIS Docker benchmarks. If you haven't checked this out, there's a bunch of different best practices, guidelines. Section 5 specifically calls out runtime security, and this will give you a list of, I think, 32 different things where you want to check if users are using privilege, the container limits things that I talked about before, and a bunch of other steps that you should follow as you move into production with containers. Next, with Kubernetes security best practices, they've already got RBAC built in, pod security policies, limiting the amounts of restarts, network policies, things like that. So Kubernetes by far has a ton of built-in security options here that you can use and leverage to make your infrastructure more secure as you deploy these services. And then also build depth in your open source tools that you have in your environment. Things like Quay and Claire, Sysdig Falco give you open source abilities for scanning, for behavioral analysis, and then existing tools like SecComp for your syscall profiling and things like that. There's a ton of default things with security that are really going to give you a defense in depth as you move into your containers in production. And then also unify security and resource availability. So definitely monitor your container resource impact. So this is back again to the limits that we were talking about before, but then also monitor the density and everything else that's happening in your environment as it's scaling, and then how specific network connections are affecting containers and everything like that. You really need to monitor more of this performance stuff because now your infrastructure is split up into thousands of different components rather than just a physical host that you were running on before. The other thing that I've seen from every orchestrator, crash loopback attacks. So there's some type of time where your container is starting over and over and over again. You definitely want to set that restart limit. So the container will just stop respawning and then get notified of that rather than getting in this crash loopback that can take hours before it really manifests in your system. And then also map all the connections and the performance. You really need to be able to see if that container, if the connection is happening from your host, what container it's happening from, and then actually the process inside that is initiating that connection. This is something where these are really getting abstracted away, and having a clear, easy way to look at this will make security from your security perspective much easier. All right, so now's the time where I'm actually going to pause and put on another poll and then check the questions that we've got on so far. So I'm going to launch for what is the primary orchestration tool that you're using in your environment, and then I'll cover a little bit of that as we get on to the questions as well. Okay, so an awesome question from Adam. If sidecar containers are not recommended, what are suggestions for running security-focused services like logging, traffic routing for L7, et cetera? So I've seen a couple different options here. What I've seen logging tools do is basically you'll set one agent on the host that's going to listen to the standard out for each container and pull from there. The other thing I've seen is people looking at kernel activity via BPF. We look at all the system calls that are happening. So it's basically one agent that's going to see the syscall stream and everything that's going on there. All right, we're at 75%, so I'm going to close this one off here. And let's look at the results. So by far, it looks like Kubernetes at 45%, with OpenShift at 4%, Mesos at 4%, a good handful of Docker Swarm here. I'd like, if you're chatting in and if you're using Docker EE, that would be good to learn about as well. And then 29% at none or other. So one of the other things that I'd really recommend as you get into your container lifecycle and into production and things like that is that you choose an orchestrator early because it'll make a lot of your security decisions and your scaling decisions and things like that easier as you go through that process. And I know on DZone, they've done a bunch of webinars about comparing different orchestration tools and things like that. So definitely check some of those out if you haven't decided on an orchestrator yet. Cool. So next I'm going to move on to incident response and forensics. And one of these things that you really want to do is have an incident response strategy. So you want to have people on your SOC team that are container experts, and then get your teams comfortable with the capabilities of containers. So one of the my favorite things to do is to start teaching people how to commit containers based on policy violations. Here you're actually going to build a new image based on that current state, and then you can run it outside for testing, compare it to the image that you originally deployed with, and all those kind of things. Also, make sure people understand the difference between killing a container, stopping a container, pausing a container, and all those different types of things. Next, because containers are ephemeral and the way that they use resources is different, you got to get your teams comfortable with container native tooling. So Sysdig Inspect is an open source tool that we have for a GUI base for system call analysis. There's tools like CTOP, which are kind of like HTOP but built for containers, and then things like Prometheus, which will pull in metrics, and all those kind of things. So if you're going in and looking at the activity of a container, everything that's happening, make sure your teams have the tools that'll make them successful as they do that. And then build out those test cases and playbooks. So containers are new, forensics is different. Make sure people understand the challenges, and then you go through those different test cases and things like that before it happens. A lot of our customers, they learn when an event occurs, and then the more you can kind of build that into your institutional knowledge with playbooks or things like that, it'll make it a whole lot easier for different teams to get up to speed with containers. The way that we've seen containers adopted within the enterprise is it usually starts off with some project. That project gets pretty successful, and then it turns into an organizational initiative. So really build that foundation of your knowledge, and then you can build it out, scan it, you can deploy that out to multiple teams and make their life and their adoption patterns much easier. Back to capture everything. So you really need to embrace the ephemeral nature because it's awesome that I can go and restart a new container, kill something, get something going quickly. But you need to be prepared to preemptively collect data. So whether that's a system capture, whether that's logging before the event, things like that, that data needs to be collected and readily available. You don't want to have to go in and take that capture once you see that event has occurred. You want to be able to kill that container as quickly as possible. Also, because of orchestrators, you really don't need to give your teams as much host access. They should be interacting directly with the orchestrator. So don't enter production environments, execute system dumps and forensics remotely, and then pull that outside of production to do that analysis. And then with that dump, there definitely needs to be some type of way that you can play it back, filter through it, so then you can do troubleshooting after the fact that the container has been killed. Cool. So now I'm going to talk a little bit about what we do at Sysdig. We're a single unified container intelligence platform to run containers and microservices in production. And so what that means is we enable you to monitor, troubleshoot, secure, and do deep forensics from a single container that's installed on the host. And then I'll talk about that a little bit further as we go through our architecture. So a background of our company, we were created by this guy named Loris Dejuani. He's the co-creator of a popular network packet analyzer called Wireshark that had 20 million users and was really kind of the basis of Sysdig and our open source tool. So we started off as an open source project. It's got millions of downloads, hundreds of thousands of users. And it's kind of like if you took TCP dump, strace, lsoff, htop, and rolled it into one tool. On top of that open source visibility, we built Sysdig Monitor and Sysdig Secure and have 300 plus enterprise customers that are running on top of that platform. And then have really rich integrations with OpenShift, Docker, Kubernetes, Mesos, all the different orchestration tools. So you can look at your infrastructure and your containers through that orchestrator lens. So I'm going to talk a little bit about our architecture now. It's built up of two main components. Container vision, which is how we collect data from your infrastructure. So what's going on inside the container, your host, your network, and then service vision, which is how we hook into your orchestrators and your cloud providers to enrich everything we collect from your hosts with that orchestrator metadata. That all gets sent to our backend, which you can use as a SaaS service, or you can deploy it on premise, managed by Kubernetes, managed by OpenShift, or just have it packaged up in containers. And then from there, that single agent and that single backend is going to give you monitoring tooling, security tooling, forensics tooling, all from that instrumentation point. So this is going to kind of touch back to how you can instrument a host and one of the examples and how we do it. So what we're looking at now is I've got a simple host running. I've got a custom app container running here. I've got an Nginx container running, and our agent will install as a container or a process that's running on that host. And then from here, we're actually going to instrument the kernel. So we can see every single system call that's happening from inside your containers. And then from there, automatically collect any user command that's executed, events like a container pull failed, a replica set scaling, a container out of memory, things like that. And then also pull in all your performance metrics. So anything that you're exposing via StatC, JMX, Prometheus, all of those will get pulled in automatically because we can see the protocol without you needing to do any type of additional exporter setup. And then we'll also have the full incident records of every single system call that happened pre and post any policy violation. So it's really a single instrumentation point to see any network connection, any file that was accessed, any process that's happening on the host or inside the container. On top of that, we hook in with your orchestrator, so Swarm, Kubernetes Mesos, and what you guys are deploying from a physical perspective looks a lot like this. So you've got a bunch of different hosts that are running with multiple container services running on them, and Service Vision will hook in there and then pull in all that orchestration metadata so you can think about your service as a logical entity. So that way you can say all the different Kubernetes pods that roll up into my Redis deployment shouldn't have any outbound connections. You can do the same thing with services, with Swarm, and really think about things and protecting them from that logical service perspective, and regardless of where that physical host or container is running. So that single instrumentation is the basis of all of our open source tools. So Sysdig, Sysdig Inspect, Sysdig Falco, and then Sysdig Monitor and Sysdig Secure as well. So what I'm going to get into next is actually a live instrumentation. But before I hop over to that, let's see what questions we have from what we've covered so far. So it looks like ECS, we have full support for ECS as well. The specific orchestrator based from a security point of view, it really depends on kind of what your workloads are running. So if you're doing some more big data workloads, you have a lot of VMs, maybe DCOS could fit you better. Kubernetes in that community has a lot already built in with the network policies, pod security policies, and things like that as well. All right, so what I'm going to do now is actually hop over into an environment where we don't have anything instrumented. So what we're looking at now is an empty environment here. I've got Sysdig Secure, Sysdig Monitor up and running, and I can do a quick Docker PS. So we can see I've got a simple WordPress app running here. We've got some HA proxy services, some MySQL containers, and then a bunch of different WordPress services. And what I'll do now is go and copy our agent installation command. And let's switch over into Sysdig Monitor so we can see all the real-time data coming in. And let's remove this -D so we can actually look at the output and see everything that's happening on my system at this point in time. So let's run this. And what's happening now is we're looking at the version of your kernel. We'll build the module on top of that. So it doesn't require a kernel restart, anything from that perspective. And then we'll start doing a bunch of different checks. So we'll pull in your command line history. We'll look if you have JMX metrics coming in. We'll look for any Kubernetes certificates, Docker certificates, Mesos, OpenShift, all those kind of things automatically. And then from here, we can actually see my host popped up. So if we open this, I can see all the different containers that are running. I can click on this host, see performance metrics about that host, and then actually go in and look at something like a topology map. So I can click on my network traffic here, drill into this specific host, see every single container that's running, all the way down into actually the individual process that's running inside each container, all automatically. The other really cool thing to look at here is I'm also seeing the inbound and outbound connections from processes. So this SSH process I have from our local office wireline provider, and I can see it's got an inbound connection to that remote EC2 instance that I'm looking at right there. So this gives me a quick overview of everything that's happening, and then the performance, the network connections, and any dependencies that I may have. You can also go in and look at something like this MySQL container, switch over to a MySQL-based view, and then automatically see things like number of requests, number of errors, top queries, slowest queries, all automatically without you needing to do any type of instrumentation. Here, we're actually decrypting that TCP connection, so you can pull it up out of the box. All right, so now that we've kind of seen some of the visibility that you can get from a performance side, let's go look at what we can do from a security side. So first, let's go touch a file below binary directory. So I'll say DZone is hacking me. Do that, and then maybe docker exec -it. Let's go shell in a container. You should always know if you have users shelling into containers in your environment, because basically they can execute anything from it within that container and access things outside that container. So there's a lot of kind of ways you can hide activity by doing it in a container. So if any individual user gets access, that's something that you want to be notified about pretty much right away. All right, so let's switch over to Sysdig Secure and go over to my events feed. And let's move this to the last minute here. Look at my commands history. I might need to do a quick refresh. All right, so we can see first this policy violation from a specific shell in a container, and then I can actually see the individual container that it came from. Click on that, see that the user spawned a shell. I get details about the individual host and then the container that it happened on, and then from there, the command that was executed, and then drill down and see any commands that were executed across my environment in the last different time scoping and things like that. So I can actually see the docker ps command that I actually touched that binary directory, then shelled into the container, and now I've got a bash shell in the container. And then anything that's executed from there on will also be automatically tracked. So quick overview of how easy the installation process is and some of the default things you'll get out of the box from the Container Intelligence platform. So what I'm going to do now is actually move over to a more robust environment with Sysdig Secure running and Kubernetes and things like that. So what I'm going to talk about now is the different policies that we have running. There's a bunch of different default policies about files being accessed, privileged containers being run, and these are all policies based on CIS benchmarks, things that we've learned from monitoring and managing millions of containers, and then also default rules from Sysdig Falco, our open source tool that the community has contributed to. So we have a lot of contributions from cloud.gov, Yahoo, different organizations that are using that to protect their environment from an open source perspective. But pretty much every security policy people do on an image by image basis. And what you really care about is protecting those services. So now let's group these policies based on where they're applied to. So I can see these policies are protecting my hosts and containers. Let's go and look at the different scopings that we've got here. So now I can see different policies that are affecting a specific deployment. Click in on a policy, and for this case, it's scope to not allowing any outbound connections from this Redis deployment. If I wanted to go and add this to different database services, I can quickly go add Mongo, add MySQL, do something like that. And then this policy, since it's set at the service level, is then going to protect every individual container that runs into that service. From here, you can take actions like stopping a container, pausing a container, or creating this Sysdig capture. And this is where you can tune the amount of data we'll collect pre and post this policy violation. So if you want to collect the 5 seconds leading up to and the 20 seconds after, this is going to dump everything that's in our ring buffer that the agent is pulling from to see all of that activity. So this is a quick overview on the policy side. And before I get over into events, I'm going to stop again to see the different questions that have come in so far. All right. Good question about the agent overhead. So what's the overhead of collecting all the system calls? How does this affect the performance of my system? Basically, we, on the monitor side, cap the agent at 5%. Across our customers, we usually see the agent running somewhere between 1 to 2% of the host CPU. But for the metrics we collect, we'll start subsampling if the agent hits at 5%. And then on the security side, all of the detection is done at the agent level. So within there, we'll just see those without having to pump those metrics to the back end or anything. Another question about the OS instrumentation layer. So one of the things that we do with our module, the module is actually fully open source. It is pre-compiled with CoreOS, so it's already included in a bunch of different distributions, and that is basically you're going to need to run the Sysdig agent to be able to pull from that module. All right, so let's go move over into events and look at how we can see what's happened in our infrastructure. So first, let's look at it from a traditional perspective, and let me look at everything that's happened over the last day. So here I can see my hosts, the containers, which have had policy violations, drill into those. But like we talked about before, you really care about protecting those services. So this grouping, you can switch and have it based on Mesos, Marathon, Kubernetes, really whatever you have running, and look at your infrastructure from that logical perspective. So now I'm seeing the different namespaces. The better way to actually look at this is from the topology perspective again. So I can see all my namespaces, which have had security violations, and then drill down into any specific namespace, see the individual deployments that have had issues, and this will look the same with if you're using Swarm, if you're using Mesos. You can build out this hierarchy however you want, and then drill down into a specific pod and container that had an issue. So one of the things that we can do here is double click on this, and let's switch to my grouping here. So let's go back. I can go into that WordPress demo, click on that specific policy that was violated, click on it again, and we'll get the details about where it happened from that logical perspective as well as that host. So you can quickly figure out if you need to go patch your firewall on that host, or if it's something that's affecting your service. So if it's a host-based issue or if it's a Kubernetes-based issue, you'll be able to see pretty quickly right away. From any policy event, we can go click on the commands. And this is kind of one of the typical incident response workflows that we see from our customers all the time. So I can click on view commands here. It'll drop me back in time to when that policy violation happened. So this happened yesterday around noon. I can see the user spawned a shell in a container, then curl down some URL. We can get further details in here that it looks like they actually curled down a rootkit, then went and untarred it, and then have basically installed it on my machine. So this is something where I'm definitely going to want to go in and do further analysis of what happened at that point in time. So that's where you can open up the captures. And this is really important from a forensics perspective because now I have this dump of everything that happened. And you can open it up with Sysdig Inspect. So what we're looking at now is a high-level overview of every single system call and every single piece of activity that happened on my host at any point in time. So the first thing you'll want to do here is overlay that specific point in time when that violation happened, and then isolate a time window around it. So we can look at, okay, this is the 13 seconds around that event, and then start overlaying those executed commands we know that were malicious, start overlaying things like modified files, access files, network connections, net bytes in, to quickly spot trends across file system, network, security events, all really quickly in my environment. So since I can see this correlation, let's go and isolate down into some sub-second granularity around that. So now I'm looking at basically half a second window around this security event, and then I can drill down into those executed commands again. So we can see, all right, this is when that tar command was executed. But then we can actually go a step further and double click on that individual process and start to see the activity that's happened there. So since all this file activity happened, let's go and look at that first. And if I overlay files, what I'm looking at now is every single file that was written from that tar process when that rootkit was untarred. So these are all the new files that were introduced to my infrastructure inside that container. And then I can go in actually another step further because we can see all the different system calls and then look at all the IO activity that's happened. So I can actually go in here, use the IO streams functionality, and start to see the individual contents that were written to that README file inside of that container. So the really cool thing to see here is we've gone from a simple policy violation to the commands history, seen that we want to execute, kind of investigate further, and then have gone in and looked at basically a really clean way to look at all the system calls and build it through a forensics workflow. So now here's another time where I like to kind of stop and pause for the different questions that have happened so far. All right. There's a bunch of questions on different orchestrators and what to use. So really, we're orchestrator agnostic. We'll support any of the different orchestrators that you're using in your environment, whether it's Swarm, whether it's DCOS, things like that. So really, it's up to the workload that you want to use, and then how much you want to kind of abstract your services from there. So if you really don't want to manage Kubernetes, there's things like EKS, there's things like AKS with Azure, there's GKE with Google that make it setting up a Kubernetes cluster as simple as a one click. Then there's also things like Rancher, if you want to do other easy ways to get orchestration up and going, or you can roll your own and use OpenShift, Mesos, DCOS, or just raw Kubernetes. So it's kind of up to your teams, the amount of flexibility and control you have, and then how big your team is. With Cloud Foundry support, we will run on basically anything Linux here. There's work that we're doing with the Garden runtime to support that as well. All right, cool. So the next thing I wanted to look at really quickly is go over to the commands history and see how you want to think about what your users are doing across your systems. So what you really want to do now that you have containers is log all those different commands that are being executed across your entire infrastructure and be able to filter them based on what people are actually executing. So you can see the different hosts, which commands have been executed, if something has actually happened inside a container, all those types of things. And then from here, you can click on any individual command and actually filter based on that. So if I want to see every single sudo command that's executed across my infrastructure, I can hit add here. We'll see all the different sudo commands, what host it happened on, what container. I can click on an individual host here, isolate that host, and then also go in and isolate a specific user. So if I wanted to look at this individual user here, now I'm seeing every single sudo command that they executed. So it's a kind of quick way to drill down, see what developers are doing, and the directories that they're dealing with, the user ID, the PID, and then the command line arguments that they're adding as well. All right. One last thing that I'm going to show a little bit on the, so we'll talk. So it looks like we have a bunch of questions coming in about the ecosystem. So how is Sysdig and Dynatrace compared? Are these in the same visibility area? Yeah, so really a lot of what I've covered today has been on the security side. We also have the full monitoring stuff that I showed a little bit earlier. We've done webinars on DZone. The big difference between us and Dynatrace is from that single agent, we can give you all this security stuff as well as your performance monitoring. So it's really one agent to do both, and it's fully container native. So awesome question there, Vimal. And then actually right now, let's just open it up to questions and drill down into the different things and how you want to think about security. And then I'm also happy to go back into the things we talked about in the slides and talk about what you want to think about at deployment security, what you want to think about at runtime and forensics and things like that. Okay, Dylan. So can you go into a bit of detail about storage requirements? Awesome question here. On the storage side, if you're using us as a SaaS platform, we'll store everything from you. If you're using us on-premise, everything's managed via containers. So you can deploy us on-prem. We use Cassandra to store all the metrics. We use Elasticsearch for all the custom events. And then kind of how big your backend environment is, it really depends on the amount of hosts that you're monitoring and securing. Is this a production environment on the demo? Yeah. So production environment, this is something where you can spin up as a trial, do all those kind of things. What I would recommend anyone doing if they want to get started with a trial, you can just go to our website, spin up a trial there, and have kind of an easy way to get the agent installed, cover everything that I showed you before. The other thing I want to touch on really quickly from an admin perspective on the security side is you kind of want to limit the access that different users have. And so that's why we've built this functionality of teams where you can limit the scoping of a user based on any piece of host or container metadata. So if a user was only in charge of securing a specific Swarm service, when they log in, they'll only see data for that service. They can only add policies for that service. They'll have their own set of dashboards and alerts at that service level. And this is also really nice on the monitoring side too, where you can go in and see basically only the metrics that are related to a certain service, and you don't have to go in and switch between other things on the fly and kind of get stuck with that information overload and pager fatigue and things like that. All right, looks like the other saw some questions. Okay, so from Ralph, Sysdig runs on the cluster considering K8's cluster, or on the EC2 machine considering AWS. Yeah, so we're on every physical node that's in the cluster. So with Kubernetes, you would deploy us via the daemon set. We'll be on every node there and then get full visibility into everything that's happening there. And then we communicate with the different APIs. So your deployment APIs kind of will interact with your Kubernetes master, pull things from there, and get all that environment metadata in. The same thing will pull in from EC2. So if you have things from CloudFormation and stuff like that, we'll pull all of those in. All right, so let's go through questions now. Looks like, I mean, we've already had 30 or 40 questions, but I'll be on the line here until the top of the hour to go through any other questions that you guys might have. So Philip, Vimal, Adam, Michael, Corey, Mike, awesome that you've sent some stuff in. Let's keep those going, and I'll be here to address anything else that you've got. John, Jose, Kartik, Kelly, anything on your side?
No, not from this side right now.
All right. It looks like we just got a question about Prometheus and how Prometheus can be used from a security perspective. Great question there. a lot of tools now, you want to kind of unify your SOC and your NOC and the different things that are going on in your environment. Basically with Prometheus, it gives you another way to kind of have that time series information about your physical resources. And you can either choose to install Prometheus and manage it yourself, or we'll ingest those metrics for you, and then you can graph and alert on those from a security perspective as well. All right, Alan, if I want to install Istio and Conduit on a Kubernetes service, how will that work with those tools? Yeah, so we work really closely with companies like Buoyant that are building services on top of Istio, and then we'll also kind of leverage the things that Istio exposes to bring in metrics and stuff like that. We're also looking at ways you can leverage BPF and other facilities to get all the information from Istio. So depending on how the different traffic is being tunneled, we're working closely with those different service mesh providers to pull in the information you need to configure network policy and to do things like that. How does this integrate with container CI/CD in the deployment pipeline? Yeah, so let me actually hop back over into the environment really quickly. And based on any policy, you can create them via the API. So there's a bunch of different macros that are built in here for all your classic examples. So if we have a list of known containers, then that can be modified to pull in your list from your registry from things that have been signed, and then we'll hook those in and kill that container if it's not one of the trusted ones that's running. All right, well, everyone, thank you for joining. We'll follow up directly as well to have a list of the slides. We'll put them up on SlideShare for you to access, and then DZone will have the recording available and everything like that. So thanks everyone for joining. Hopefully this was useful, and for the 80% of you that aren't in containers with production yet, I'd really like to kind of hear about where you are in your journey, how we can help. And it seems like there was a ton of interest in the orchestrators, how to choose between them, things like that. So really feel free to follow up with us directly, and we can dive in a lot further on those topics.
Well, thank you, Knox, for a great presentation today. I'd also like to thank today's sponsor, Sysdig, for providing the DZone audience with a great webinar presentation. And lastly, thanks to everyone who joined us for today's event. We hope you learned something new today that will help you in your developer career. Have a great day, and we'll see you next time.
All right. Thanks, everyone.